Precision is a very important concept in the machine shop, and different tools for measuring will give you different levels of precision. This time we're going to talk a little bit about the different tools that you might find in a shop for measuring various things. What we have laid out here, we're going to start talking more or less from our least precise tools on up here through some of our most precise tools, and then we'll also discuss some other various odds and ends kinds of tools that you might find around the shop and how they're used. Okay, here we are over at the inspection plate. This is an extremely flat, hard granite surface. It's been precision ground, so any measurements that we take off of the base of this thing should be very accurate. Later on, we'll demonstrate how to use a height gauge that we can use right off the table here. And we're going to talk about tape measures, rulers, and scales. So starting with the least accurate of all of these, we have a tape measure. And what I want to emphasize on any of these tools is the importance of looking at the scale that you're actually working on, because they're not all laid out the same. The increments and the units measured are obviously not going to always be the same. So this is one of my favorite tape measures. It measures in feet, inches, and fractions of inches. In addition, it's measuring in centimeters, meters I would reckon on there as well, and millimeters. So tape measure, however, there is not a lot of inherent accuracy in these guys between the thermal expansion of the metal tape and just the lack of precision of a sharp edge on here. Good for general rough layouts, estimating to within, an eighth of an inch, maybe a 16th of an inch of something that needs to be cut. One thing you should always look out for on tape measures is this part on the end. I've seen people think that this means that it's broken because this part wobbles back and forth. That's actually built in by design. If you're measuring something pulling from this side, that will slide forward and allow you to pick up the very front edge of something. If you're measuring from this side and you're pressing against it, this will slide back roughly the thickness of that piece of metal and allow you to get an accurate measurement when you're pressing. So pulling and pressing, that's why that piece is there to slide back and forth a little bit. So that's your tape measure. What most people will call a ruler or a scale. This guy is also broken up into inches, fractions of inches, and then in the metric system, millimeters and centimeters on this side here as well. Not super accurate, maybe slightly better than your tape measure, mostly because you've just got a straight edge to work against. Neither one of these things is going to give you much better than maybe a 16th of an inch, basically the finest graduation that you're going to find on the ruler there. Okay, moving on from rulers, we've got these guys here, which are essentially fancy rulers that allow you to maintain a 90 degree, set this at a known distance on there. Not much finer resolution or better precision than a standard ruler, just a lot nicer to set a particular length and measure that out, and also to keep 90 degrees. This guy does give you a little bit better precision. Looks like we're getting about 30 of an inch on this guy. In addition to having our metric scale on here, millimeters and centimeters, both sides like that. So then moving up from those, we have a machinist's scale. These are much higher precision, give you a lot finer detail. See on this side we've got up to 64ths of an inch, and this is in fractions of an inch, and then on this side we've got tenths of an inch, and then 25 of an inch on this guy here. This one is handy to keep. A lot of machinists will have something like this in their pocket for taking quick measurements of parts that they're working on. And then this is one step below using some calipers. Okay, and then sometimes used with your scales, you'll have what are called transfer calipers. This allows you to take a measurement of something, a particular distance across, and then transfer that over to a scale to get an accurate known measurement on something. You can take points on there. This one would be handy for measuring, say, the inside diameter of something. And the same idea, you lay that across your scale there and get a measurement off of that. To go one step more accurate than that, we'll use some calipers, and we'll show you those in a second. Okay, now we have our direct reading calipers. So rather than taking a measurement with one device, bringing it over and measuring it on another device, both steps can introduce a little bit of error. If the part allows for it, we can read distances between, so thicknesses. In this sense, we can measure widths with this part of the tool over here. And then on the back side, the step between this edge and this edge can also be used for measuring depths or distances across. Might use that on, say, on our inspection plate to measure the total width across and something like that. 3 inches exactly, look at that. So 3 different types of calipers, 3 different scales for reading calipers, I should say. This is a vernier caliper. We'll explain in a second how to read a vernier scale. Looks a little bit different than the other ones. This is a dial caliper. It's read in a combination of the numbers on the inside plus the dial that's up there. Then everybody's favorite and the easiest to read is a digital micrometer. These have the distinct advantage of both being very easy to read, but being able to very quickly switch between metric and standard units on there. Okay, on all precision measuring tools, you want to make sure the surfaces that you're using to measure with are clean. Typically with calipers, we'll do something like this, put a piece of paper in there and just drag that off. Make sure that when you close the jaws, it's reading exactly 0 right on there. We look good on that. Now what we can do is, using the inside of the jaws here, we'll measure the thickness of our part. And this is going to be a little bit hard to do. I'm going to step around the camera here. On our vernier scale, is when we've actually got metric centimeters, millimeters, and then also inches up here. We're going to read off the inches scale. So in tenths of inches, we have, starting from here, 2/10 of an inch, and then in basically in groups of 25/100ths of an inch, we have 25, 50, 75, and then we hit the next 3/100ths of an inch, essentially, 0.3. So on our scale, measuring this thickness that we've got now, we've got 2, and we've passed the 25, we're slightly past the 50 on there, but we're not to the 75 yet. So we're going to add 2 and 50, so we're at 0.250 and then some change. And then we use this scale up here with the 5 through 25, and it's offset slightly from the scale below. So you look for the number on the upper scale that corresponds most accurately, or most closely lines up with the number down below here. And here I'd say somewhere between the 5 and the 6 there, look like they line up. Maybe the 7 lines up pretty closely. So by adding that up, we've got 0.257, but 2.257 is about what I'd give that measurement on the vernier scale. So let's check it against the other instruments and see what they say. Okay, switching to our dial calipers here. Same idea, you're going to read the distance off the first decimal off the scale on the inside here. So let's bring that in. We've got 0.2 and some change. Put that right on there. Much easier to read than the last one. So we have a 0.2, and we're going to add what do we have on this dial from here. So we notice we've got from 0 to 100. So we've got 0.25, and then this one we're reading about 255. So about 2.255 inches on this guy. Depending on where I hold, there might be some burrs on there. Over here we get 260. So this actually is a good lesson to make sure when you're measuring a part to take more than one measurement, measure in a couple of different locations, make sure you're getting the most accurate. Here's 252 and a half maybe. All right, now we'll check that against the digital one. Okay, the digital calipers are nice, but they do have their drawbacks. Number 1 is that they are a little bit more fragile. Number 2, that you've got to have a battery that's working in there. They also can be susceptible to coolant or excessive oil or something like that. If you're working with a lot of coolant type cutting operations or something, you may not want to get these soaked in that. The other big thing you've got to really watch out for is if these jaws aren't completely closed and you turn this on, it just takes 0 from wherever you turn it on. So then you take a measurement out here and you think you've got some accuracy. Now return those jaws and you realize that you're actually add quite a bit to your measurement there. So you can either 0 that out while it's on. In fact, that's a good rule of thumb to take. I always, again, come back to the piece of paper, close this guy, give it a quick wipe, make sure it's all the way closed, gentle pressure on the thumb screw, and then turn it on. You're reading 0. Run it out, run it back, and make sure you're still reading 0. All right, and we'll take a measurement on our part again. We got about 0.253, 254 and a half, 257.5. And as I mentioned, the great thing about these is you can leave this right on there and just literally switch right back and forth between inches and metric units. Oh, and lastly, we'll mention this guy here. It's just a dial caliper like the other one we showed you, just that most of them usually go to 6, maybe 8 inches. This one goes up to a full 12 inches. So it can be nice if you've got larger objects, obviously, that you need to measure. Okay, and since we were just talking about dial calipers, we'll quickly talk about a dial indicator. This has a magnetic base that you can turn the magnet on and off with this lever. We usually use that for clamping onto a machine or the spindle, say of a milling machine, or the bedways of the lathe. And what this allows is to set this up and then take a distance measurement from a known point. So as our machine moves, we'll take this measurement. Not used very much now that we have the digital readouts on the machine, but before there were digital readouts, this was about the only way to really accurately measure off a part that was clamped into a machine. You can see how that moves here. We get thousandths of an inch on this scale here and tenths of an inch on that smaller inner scale there. Okay, moving on from calipers to micrometers. So this pretty much is the pinnacle of precision for the machine shop. If you've got a distance or a diameter on something that you need to measure out to more like the 10,000ths or even beyond, these would be the tools that you want to use for that. Our calipers will get us pretty close to within 1,000th, but when that tolerance goes beyond 1,000th and you need to start looking at 10,000ths of an inch tolerance, then we're going to move on to micrometers. A couple of different ones shown here. This is a vernier, old school standard analog device here. And I can show you the in a second. We've got our digital ones here, which is held in a little just kind of handy bench top holder. And then this lastly is a vernier style like this one here. It just covers a little bit different range. This is a 1 to 2 inch. You'll notice that most of these micrometers only have about 1 inch of usable measurable range. And so if you need to measure anything over an inch, you start looking at micrometers that go from 1 to 2 inches, 2 to 4 inches, 10 inches to 11 inches, that sort of thing. But generally, they only have about an inch worth of movement in them. One thing that you'll want to make sure if you're working in a machine shop is that you sort of demonstrate how to hold these carefully. A lot of people carrying them around like this, not good. Typically, when you're going to hold a part for inspection, you wrap your finger, 1 or 2 fingers through the opening jaw in here. You'll turn this with this guy here, and then you'll bring and take your measurements like so. This kind of helps to ensure that you're less likely to drop these tools. These are usually start at $100 and go up to several $100s easily from there. So you want to be very, very careful with these and handle them delicately. So if you're in a machine shop and they see you, carefully handling something like this, then feel a little more confident maybe that you know what you're doing. Okay, we'll take a look with the analog vernier micrometer here, and we'll take a measurement on our part like we did before. I want to mention that just like we did before, we want to bring our jaws basically closed, slide a little piece of paper in there, and in this case, we can use this little thumb screw. It's got a ratchet on there, and this adjusts our tension to just the right amount. Obviously, if we really cranked this thing tight, we could actually open up the jaws of this a little bit and get an erroneous reading. So this just keeps just the right amount of tension on there, and we'll slide that paper out, thereby cleaning off the surface, and we'll confirm that this sets right at 0. Hopefully you can see that on there. And then we'll go ahead and take our reading. So it's tradition, if you will, to sort of hold a micrometer like this. It ensures that you get a good grip on the tool, while then coming back in and measuring gently like so. Okay, we're going to use that little ratchet, make sure we're right on there. Okay, so in reading the vernier, it's very similar to before. So we've got tenths of inches on this scale here. We've got 25ths, at each line. So I've got 2 tenths, 25, 50, and then we're reading on this line, and then each line after this 5 or the 0 from here. So we have 0.2, 0.25, 0.250, and then we're going to add 5, 6, 7.5. So we've got 0.257.5. That's what we can read out on this guy. And that actually agrees pretty closely with our calipers that we had. We'll take another measurement, another location here. Just kind of confirm that thickness. Okay, so we've got 0.25, 0, 1, 2, 3, 4 and a half. So 0.2545 would be our reading on the thickness of this part there. All right, well, we'll take that measurement with the digital scale here now. Okay, hopefully you can see that digital readout on there. As I mentioned, this little bench vise makes it a lot easier to hold the micrometer. And I can actually reach around this side, and we'll run that up here. That ratchet. So this one is reading 0.25440. So we've got tenths, hundredths, thousandths, 10,000ths, and it's making us believe maybe it can read 100,000ths of an inch. That is in this. I wouldn't take that one with a lot of credit, but we're definitely getting to the 10,000ths measurement on that. 2558. All right. Well, and lastly, I should mention when you're finished using the tool, obviously wipe it down, make sure it's clean, there's no chips or oil on it. But one thing to avoid doing is closing that jaw and putting it away with the jaws closed. As temperatures come and go, the metal will heat and expand, and you actually can be putting pressure on the jaws in there and so forth. So it's always a good idea to leave a small gap in there. Also makes it a little bit easier for the next person who's going to come in, obviously put their paper in there and wipe that clean. So always leave a small gap in your micrometers before you put them away. Okay, this little tool is a depth gauge micrometer. As I mentioned, with the regular micrometers, they're usually only good for about a 1-inch range. If you need to keep the precision that you would get with a micrometer, those 10,000ths of an inch measurements, the calipers do have a way of measuring the depth, but if you need greater accuracy, this device will allow you to do that. So to zero this, we're going to back this all the way up to 0, and we're going to confirm on a flat surface like our granite inspection plate that we are in fact at 0. So just touch that off there. And about 1,000th of an inch, 10,000th of an inch off there. So we'd be right about there to be 0. Now we would dial this forward, and let's say we wanted to take the depth of the measurement of one of the holes in our plate. Run this guy until we hit a little bit of resistance. Right about there. And this will be another measurement for the thickness of our plate. Starting from the other side, we've got 250. We're not quite to 275, so 250 plus 10 is about 0.260. So, we may have some burrs on there, maybe up from the plate, but, we know that should be about 2.558, 5.7, something like that. So, if you need to measure a hole that's deeper, the back of this part comes out. Slide this out, and we can put in a longer, and these are all calibrated. This will slide through like this. Put that back piece back on there. And now we can measure in the 3 to 4 inch range. And we've got a couple of different lengths rods for doing that. All right, so that's your depth micrometer. All right, this is our inside radius micrometer. So this has a little dowel at the back here, and it allows us to reach inside of a circular shape and measure from the inside to the outside. If we had the flat anvil like you'd find on a standard micrometer, you would get an error between the flat disc and the edges of where it's touching the inner curved surface. So for example, if I wanted to measure the thickness of this wall in here, if I had a flat piece like it would be this way, then I would get an error because the rounded shape of there is not matching up the flat on that. Or if I rotate it this way, then we can put that pin inside there. So we can measure that thickness in there. This has a built-in ratchet in the handle there. Pull that out. Take a reading off of our veneer, 0.22550, so exactly a quarter of an inch, 0.250, maybe 10,000th or something. So that's your inside diameter micrometer. Okay, similar to our transfer calipers, we have here it's basically a bore gauge or a hole gauge. This one is rated for from 0.3 to 0.4 inches, and it's used by simply inserting this into the hole, turning until you get a little bit of friction on that part in the hole, about like that, and then bringing this over to your micrometer. And we'll measure this out across here. All right, so about 0.3756, which is right on because we know that these holes should be, these are 3/8 of an inch and these are 1/4 of an inch. So we take a measurement inside diameter of a hole, particularly smaller holes where other tools might have difficulty getting in there. Okay, next we have a couple of gauges or gauge sets. This one is for identifying drill bit size or basically diameter of a shaft that you might put in there, the shank of a drill bit. This makes it quicker and easier to identify what drill bit you're using. This is the same idea but for wire gauge. So you may have heard of a 14 gauge wire, a 16 gauge wire, something like that. If that wire passes through there, if it's in that hole, and you know the thickness of it. So examples of gauges. Okay, a couple of other gauges you may come across in the machine shop. This is a thread gauge. You can see on here each of these things is stamped, so this would be 42 threads per inch, 34, say 24 threads per inch, something like that. And you can use this and just lay this onto the threads of a bolt or the inside threads of a pipe or something. And if you get a very close match, no light fits between any of these things. If you hold it up to the light, you don't see any gaps in there, then you can use this to determine the number of threads per inch on a particular piece. These are metric on this side and imperial on this side. All right, and this here we have a surface finish scale or gauge, and you basically just kind of visually identify which of these surfaces, which of these textures kind of most closely matches the finished machine of your part. A lot of times your parts will have call-outs for a particular grade of finish when you're done, and so you can use this to match up and see if you've got reached that particular grade of finish.